Hello, this is David Klee from HeroFlux Technologies. Today, we're going to talk about Windows Perfmon and how to set it up properly. Perfmon, or the Performance Monitor, is a utility built into Windows that collects performance information from anything service or program related on the system that knows how to register itself with Windows management instrumentation. This can include things like Microsoft SQL Server, or IIS, or remote desktop services. Collecting ongoing performance information is absolutely critical for real-time triage of performance challenges, but it's also great for analyzing day-to-day to determine resource consumption trends and patterns in your server environment. It's built to be straightforward to use, impose almost no performance overhead on your servers, and since it's built into Windows, it's absolutely free. Perfmon counters have 3 layers. The first is the counter object, and that includes high-level groups such as processor or memory or network adapters. The next are the counters themselves, and these can include specifics for that counter object, such as the percent CPU consumed, or page file consumption, or storage latency for each of those objects. The next layer is the counter instance itself, which gives us the specific components such as the number of the CPU that we're studying, or the disk drive by mount point, or the network adapter by name. All of these details really matter because we need that level of granularity to provide a very thorough analysis. Having low granularity means that you might show overall CPU consumption averages, but if one of those CPUs is spiking to 100% all the time and the rest are quiet, the average might not reflect the single CPU that is being really erratic. Or it could be a scenario like a 32-core SQL Server with 2 CPUs at 100% and the rest are relatively idle. That averages to roughly 10%, and that does not tell you the complete picture that 2 of them are maxed out, and the workload is not parallelizing that command properly. Perfmon can be used in 2 different ways. The first is the real-time collector, and it's great as long as you know how to basically read the matrix, because there is a ton of information all flashing by you every second. It's not stored anywhere by default, and you have to really be able to watch for any data points that matter to your investigation very carefully before you pick out anything useful. That's extremely difficult in the event that something's actually happening right now. It also disappears after a minute, so not having the history of what happened in the past makes it very difficult to review. So what I like to do is to set up ongoing 24/7 collection at a collection granularity that's granular enough to get the information that we actually need, but not severe enough to actually give us any sort of performance impact on the workload itself. I usually do every 30 seconds. Greater than 30 seconds means significant spikes or changes might not be picked up through the law of averages. Anything less than 30 seconds could cause a noticeable performance drain on the server, and it is never a good thing to have the thing monitoring your system slow down the thing that it's monitoring. So I'm going to show you how to set this up for 24/7 collection, and let's dive in. Let's open Perfmon. Hit Start, type the word Perfmon, and hit Enter. You've got monitoring tools and data collector sets. If you're looking for real-time information, select Performance Monitor. Otherwise, we're looking to set this up to collect 24/7. So expand data collector sets, user defined, and what we're going to do is we're going to create a new collector set. So right-click on user defined, select new, and then data collector set. Type in a name here to identify it as yours. I'm going to put in my company name HFX. We do want to create manually the counter set under advanced. So here, create data logs, select performance counter and hit next. We want our sample interval to be 30 seconds. We want this to be 30 seconds because anything more aggressive than that is going to be more overhead on the system. Anything less than that doesn't give us the granularity that we're really looking for with this sort of collection, and it's low overhead and doesn't take a lot of space. Click on Add for our performance counters. As you can see, there are a tremendous amount of counters that we can select from. For the full list of performance counters, visit our website here, hfxte.ch/perfmon. This is going to give you a PDF of all of the counters that we're looking for. If you want to click through and manually add these, go ahead and skip a little further into the video. Otherwise, we're going to walk through all the counters that you should select for basic SQL Server performance collection. Okay, first of all, it's under processor. What we're going to do is select the things that we care about related to overall usage, processor usage by process, and processor usage by system kernel time. This is also listed here as privilege time. One big item to note For every counter that we have, you're going to want to select all instances and not the underscore total that is there by default. Selecting all instances gives us every single item, such as CPU number, hard disk by letter, things like that. Okay, next up, memory. Big thing here is available MB or megabytes. Note there are no instances for this selected counter. Some counters don't have instances. We also care about page faults per second, page reads per second, and page writes per second, and pages per second. Okay, for network adapter, we're interested in our packet outbound and received discards and errors. And these are really important because if there's networking issues either upstream or with inside this server, this can help us troubleshoot those items, as well as total bandwidth. Okay, for physical disk, we're going to look at percent idle time, average disk bytes per read and per write, average disk seconds per read and write, that's going to be storage latency once you convert it to milliseconds, average disk read and write queue length, disk bytes per second, read bytes per second, write bytes per second, and disk writes. Make sure again to select all instances. Next, paging file. We're very interested on what our paging file is actually doing. Next, percent of maximum frequency. Note this will also give us our Newman node as well as the per CPU total, and this tells us if we're power scaling any of the CPU cores. And then under processor information, processor queue length. It's an indication of internal CPU scheduling pressure. If you are on the VMware platform, we are interested in the active memory and the ballooned memory as well as swapped memory counters. Also, if you're on VMware, percent processor time and CPU stolen time are really important, as is effective VM speed in megahertz. That's the core counters for the Windows platform. Now, if you're running SQL Server, we have a number of other counters that we do want to go add here. If this is a default instance of SQL Server, you will see SQL Server : and then some level of counter. If it's a named instance, you're going to see MS SQL and then the instance name and then a colon and then the counter set and counter the instances. So if you have one or more instances on the machine that are named, make sure to check those out instead of looking for the regular ones. The full explanation for all of these counters will be found in an upcoming video. One interesting one to note here is batch response time grouped by milliseconds. It's really interesting. You can actually baseline your environment by these counters and see how things change with things like service packs and cumulative updates and Windows updates even. Buffer cache hit ratio under the buffer manager, as well as page life expectancy, free list stalls, page lookups, reads and writes, pretty important memory counters. Now under buffer node, database pages, local node, and remote node page lookups, as well as page life expectancy by Newman node. And transactions per second by database, which is our named instances here. Under general statistics, number of user connections and transactions per second are kind of important. Under latches, latch waits per second will give us a good idea of internal latching, and the next counter is locks, same kind of thing. Batch request per second under SQL statistics, as well as compilations and recompilations, are also quite important. We are done adding the core counters. Go ahead and click Next. If you want to save these under a different location than the default, which is C drive, usually C drive, perflogs, HFX, and then whatever you name the collector, feel free to change a location here. I'm going to leave this as default for now. And click Next. Okay, right now we're going to save and close this. Our new counter is defined here. It's just not started yet. Okay, right-click on the collector, hit Properties. We do want to go tweak a few of these settings. Spot check to make sure the directory that you set is appropriate here. Usually these items are just fine in here. Now under schedule, what we're looking to do is to start this every single day, and then we're going to recycle it at midnight. So under schedule, we're going to start this at midnight. And then under our stop condition, because of some quirks within Windows, we're going to run this for 1 minute less than an entire day. So set the overall duration here to 1439 minutes. What this will do is stop itself about a minute shy of midnight and give it time to flush to disk, clear itself out, and then it'll restart right at midnight. On the right are our counters. If you right-click on the data collector and hit Properties, you'll see all of the counters selected, as well as a 30-second sample interval. Now under File, check your log file name. The file name format, we want to date stamp this. So YYYYMMDD, prefix this with a computer name in case you want to archive these off. And in case this thing gets interrupted in the middle of collection, we're going to append our log file. A little known feature here is that this thing can clean up after itself so it doesn't fill your hard drive up with data files that are just sitting there for months at a time. If you right-click on the collector, click Data Manager, and you'll note we can actually check how much free space we want to keep on the drive that you've selected. In this case, I'm selecting approximately 16 gigabytes minimum free, and our resource policy, every time this thing recycles, if we're going to run into space constraints, is to delete the oldest. Now, one good thing that we can do, we can also set this thing to create cab files, which are Microsoft's versions of compressed files. I don't want to say zips. And what we're going to do is we're going to create the cab file and delete the original data file after 7 days. Because I hope that we're going to be archiving these off somewhere else, we're going to have this thing after about 8 weeks go clean up itself. And that way it'll get rid of every trace on the file system. So set those and click OK. We're not quite done. Go back to Start and go Task Scheduler. This sounds a little weird, but you'll see why we need to do those. Expand Task Schedule Library, Microsoft, Windows, and go to PLA, because when I think Perfmon, I think PLA. You'll notice here under PLA, that's our Perfmon counter. So what's actually going on is this is a Windows scheduled task. Right-click on your counter and hit Properties. Triggers. You'll notice we have one for every single day at midnight, but we also want to have this thing start if the system turns on. So the scenario here is, let's say Sunday mornings, you're doing some routine patching before everybody gets up. The Perfmon collector may not turn on until midnight that night. If we set a system startup trigger to enable this, then life is good. It's going to turn on every single time that we start it up. So click on Triggers, click New. Now we want to begin the task at startup, and that's it. Click OK. There's one more thing we want to do here. Just in case, we want to make sure this thing doesn't run longer than a day. And if it's still running, we want to stop the existing instance. Go ahead and click OK. This is actually kind of important for scenarios where we have to do routine patching, maintenance, things like that that cause this thing to recycle on an abnormal period. Okay, we are done. Right-click on the counter and hit Start. You're now up and running. So if you go to the location where we told it to save the performance logs, in this case C drive, perflogs, admin, HFX, you'll notice there's individual folders and files there for each day. You may have to grant yourself permissions to get in there, no big deal. And there's our Perfmon file. Great. Everybody on the internet tells you to collect Perfmon information. Nobody tells you what to do with it. So stay tuned for a future video. I'm going to show you how to load these into a SQL Server database so that you can actually get to the raw data and start to mine the information for its value. I've just shown you how to set up ongoing Windows Perfmon for 24-hour-a-day ongoing collection. Feel free to customize this process as needed, since everyone's needs are different. The great thing is Windows Perfmon is completely free, and it's already on your Windows servers, and it is quite easy to set up and manage. The one thing Perfmon doesn't do is give you an easy way to review the contents of these Perfmon collections. Stay tuned for a follow-up video where I show you how to import the data into a Microsoft SQL Server database so that you can use the power of SQL Server and any other analytics tools you like to review this data and get to its true meaning. If this setup process was useful for you and your business, please like this video, and for future notifications for new videos as we release them, please subscribe to this channel. Thank you for watching.